Here we are given this function f of x equal to x plus minus 1 whole power x minus 1. And this function is from natural numbers to natural numbers, that is positive integers 1, 2, 3, 4, 1, 2, 3, 4, like this. Right. Now, what is the f inverse of this function? First of all, whether inverse exists. If it exists, then what is the inverse? Right. So, now here we can see minus 1 whole power x minus 1. Okay. All natural numbers. That means they can be odd or they can be even. Right. If x is odd, obviously x minus 1 is even. Right. Minus 1 power even, this becomes 1. Right. So this becomes x plus 1 if x is odd. Right. Because x minus 1 is even, minus 1 power even is uh, minus 1 power even is plus 1. So x plus 1 if x is odd. Similarly, if x is even x minus 1 is odd, minus 1 power odd is minus 1. So this becomes x minus 1. Okay. So x plus 1 when odd, x plus 1 when x is odd, and x minus 1 when x is even. What does that mean? Let's say if it is 1, x plus 1 is 2. If it is 2, x minus 1 is 1. If it is 3, for 3, for 5, for 7, because these are odd. 4, 6, 8. For 4, for 6, for 8, because these are even. 4 minus 1, 3, 6 minus 1, 5, 8 minus 1, 7. Likewise, see, 1 is mapped to 2, 2 is mapped to 1, 3 is mapped to 4, 4 is mapped to 3, 5 is mapped to 6, 6 is mapped to 5. Clearly, this is 1, 1 function. Right. Every number is mapped to the adjacent number. If it is odd, to the next number. If it is even, to the previous number. So clearly there is 1, 1 map. All numbers are mapped to, all natural numbers are mapped to all natural numbers. So clearly there is 1, 1 function. Whenever there is a 1, 1 function, we have an inverse. Right. 1, 1 functions, we can have inverse. Right. Now clearly if you see f inverse, let's say. Now what is f inverse 1? F inverse 1 is 2. F inverse 2 is f inverse 2 is 1. Similarly, f inverse 3, f inverse 3. Where is 3? F inverse 3 is 4. And f inverse 4. F inverse 4 is 3. What does that mean? See, f and f inverse, both the functions are same. See, for example, it is 2, 1, 1, 2. F inverse 1 is 2, 1, 2. 2 is 1, 2 is 1. 3 is 4, 3 is 4. And 4 is 3. 4 is 3. Clearly, this function and this function are exactly same. Right, f and f inverse are exactly the same functions. So what should be f inverse of x? It is exactly the same, x plus minus 1 whole power x minus 1. Very simple problem. The same, whatever is this, that is the same as f inverse. Right, guys? The function is same as the inverse. And why is this happening? Because this function has got 1, 2, it has got 1, 2, it has got 2, 1 also. It has got 3, 4, it has got 4, 3 also. It has got 5, 6, it has got 6, 5 also. Likewise. So, this graph, these points, whatever these points, they are actually symmetric with this line. That's why this is happening. Right? 2, 3, whatever. Whatever all these points, they are symmetric with this line. What is this line? Y equal to x. Whenever there is an inverse, right? The inverse of this function should be symmetrical with this line y equal to x. Now here this function itself, these points are symmetric with this line, right? So obviously the inverse is also the same function, right, guys? So all the points, if x y are there in this graph, y x is also there. This yx, this if this point is there, this point is also there. If 4 5 is there, 5 4 is also there in this graph. Sorry, if 5 6 is there, then 6 5 is also there. If 3 4 is there, then 4 3 is also there. Right, guys?